Good morning students. Today we are going to see a case study in testing of hypothesis in manufacturing quality control. So what do you mean by testing of hypothesis and what are the types involved in it? So we have two types in it, and one is the large sample and another one is small sample. If n is greater than 30 it comes under large sample, and when it is less than 30 it comes under small sample. So in small sample we have three tests. One is t test and second one is f test and third one is chi-square test. Similarly, in large sample we have four tests. One is test for significance of single mean, second one is difference of mean, and third one is single proportion, and the last one is difference of proportion. Now the question is, suppose a manufacturing company produces metal rods that should have an average length of 100 mm, and due to customer complaints the quality control team suspects that the machine is not maintaining the correct length. So here we are going to conduct a hypothesis test. So for this we have to formulate the hypothesis. That is our step one.
Start.
Firstly, we can see the formulation of this problem. There is two hypotheses available in this problem. Null hypothesis and the alternative hypothesis. Null hypothesis is represented as not. There is no significant difference between the sample mean and the population mean. This represents H0 is mu equal to 100. And one alternative hypothesis represents H1. H1 is there is a significant difference between sample mean and the population mean. H1 is not equal to mu is not equal to 100. This is the formulation of this problem.
So what are all the given data involved?
In the step 2, sample data collection. In the step 2, we collect the data from the product. We take 50 rods from the factory and measure their lengths and find the average mean. Average mean is 98 mm. So other given values are standard deviation 5 mm, significance level is 0.05. So in the step 3, selection of test. In this we decide to use Z test because standard deviation is already known and the sample size is larger.
So step 4, let us see the test statistic calculation. So for the purpose of test statistic, if the difference is small, likely it is due to random variation, and if the difference is large, it indicates a real change. So here we use the formula Z is equal to.
Start.
So here the formula we use is equal to Z equal to x bar minus mu divided by sigma into root n, and x bar is the simple mean. That is already said, sample mean is equal to 98 mm, and mu is population mean, it is 100 mm, and sigma equal to population standard deviation 5 mm, and n is the sample size 50. So by calculating this, we get a value of Z is equal to minus 2.83. So interpretation of Z value. If the sample mean is 2.83 standard error below the population mean, this is large deviation, that the difference is not due to chance. So if the Z is equal to 0, the sample matches population. If Z is large, the strong evidence against H0 indicates a significant difference.
Start.
The next step is critical value approach. For alpha equal to 0.05, then it is called as two-tail test, and critical value will be equal to plus or minus 1.96. The next step is decision rule. If Z is lesser than minus 1.96 or Z is greater than plus 1.96, we should reject the H0. Therefore, here Z equal to minus 2.83. Since minus 2.83 is lesser than minus 1.96, we reject H0.
So I will conclude about this testing of null hypothesis. In this case, we have taken this industrial scenario where this manufacturing of rods as the not having the average mean of the diameters. So actually, we are taking the samples of 50 samples, and we are applying this Z test on it. As this is a two-tailed test, the null hypothesis and alternative hypothesis are the opposite. As this is the difference between the sample mean and population mean. So by this step, we are integrating with the null hypothesis, alternative hypothesis, and this Z test formulation is actually the x bar minus mu divided by the population standard deviation divided by square root of n. By this formulation, we'll be applying all these and we'll be getting a critical value. By comparing this z critical value to the given formulation table of the alpha value, we'll be getting the whether we have to like reject the null hypothesis or accept the null hypothesis. By this we can, in our case, this hypothesis is like rejected. So by rejected, we have to like redefine the overall industrial expertise and we have to like redesign the diameters of the manufacturing problem. Thank you.
Hope you understand this case study.